few questions for each project because I don't want to be the only one that asking questions. And so it's for mentors, for faculty staff, and also for students. Please be more proactive.
But easy.
Don't worry, we don't ask very tough questions. And there is a Google form as a feedback for each project. So you can do it during the project presentation or during the break or after that, but just don't forget about it. Okay, here we are. So welcome to the third and the last day of project presentations. Let's start. The first project is Litigate project.
Yeah, welcome everyone. Today, Andre and me will present the task of paraphrasing. It's an NLP task, and I'll talk a little bit about Litigate first before I go further into details. Litigate is a legal tech startup. You might know them from a few lessons of why data. Their basic selling point is that they're able to analyze thousands of legal documents and can do co-references inside those documents. And yeah, our mentor was Inbal from Gong. So you also remember Gong probably from our one guest lecture. And now I'll go back to paraphrasing. Yeah, so you might have already an idea what is paraphrasing. Essentially, it is saying a sentence with different words, but with the same meaning. There's an example here, and I'll go further into details why you probably came across paraphrasing, or why you probably will come across paraphrasing. So maybe who can say from the 30 participants who has been doing NLP in the last 3 months? And probably you came across a few things. For example, you may have been working with a small data set. So you might know from image recognition that it's useful to augment the data, so to increase the training size. And you could use paraphrasing technically to increase the size of a small data set. In practice, it's also very useful for plagiarism detection and finding, of course, similar documents if you have like a search. And the main task is, of course, to test for equal semantic meanings. And therefore, it's important to understand that a sentence like, I'm flying from New York to China, has not the same meaning as flying from China to New York. So we started with a data set, and Andre will talk about this.
Yeah, so we were given by Litigate this data set, which is basically consists of around 40,000 sentences. So their structure is like this. So we have these sentences, and there were picked some verbs from it, and based on that created question answer pairs. So it's all was done manually to obtain this data set. So for this QI-SRL to create a model that could do this, probably potentially automated. Yeah, so this is created by people. So there are some mistakes, of course, like here, this is a good example of a good sentence and question answers. So people need to create questions and then mark the answers to them in the sentence. This is how it looks under the hood. It's basically a JSON. We have the tokens of the sentence. And then we have question labels. Like here it says that we have 12 of them. And like this, like where is something needed? And then it says that it is a valid question. Yeah, 2 people agreed on that. And then span is from 7 to 10, like where is something needed? Something needed in the atmosphere, for example. Okay, so the first approach, we were, by the way, working with Guy from Litigate. He was also our NLP teacher. So the first approach was to use the sequence-to-sequence model, and its primarily use is for translation tasks. So the idea was to create embeddings for each question-answer pair, like here, who went a boy, where did someone go to a pool, to create some embeddings and feed it to the encoder, and then to see like what we can get as an output. Yeah. So what happened as a result was pretty interesting. So we were able to get some variety in our output. So here you can see some examples like input, output, and the original. So from these question answers, this string of question answers, we were able to get this output, like those that could not adapt or move went extinct along with many plants. And we see that the original word was couldn't. Yeah, so at least the model knows that this kind of equal. Okay, but as you can see, this is one-to-one sentence. So another result, and we saw many of those, was that it's kind of did the summarization for a sentence. So it stripped out some parts. Like here you see that output is shorter than original, and these two pieces were omitted. Yeah. So we should know that the paraphrase task is a pretty challenging topic. So we'll go more into this. Okay. Okay. So yeah, we did also a lot of work on the data set to clean it up, because there are a lot of marks, because it's all manual. There were a lot of artifacts and a lot of noise. So we did a lot of work on the processing data set also beforehand. Okay, so Franz?
Sure. So at some point during a deep learning task, you might stumble upon problems in your model or your data set, and you start thinking about approaching or solving this problem differently. And that's basically exactly what happened on our journey. So we decided to go or to look for further paraphrasing data sets. And there's a really good example of paraphrases. It's not essentially a paraphrase data set. It was not specifically made for this task, but it is exactly what we were looking for. It is basically from Quora, the website where people can post questions. And it's a data set where the question of the task of the data set is this post on this website, is it the same as another post? So the title of a question on Quora might be, where can I buy cheese in Tel Aviv? And another person writes, where can you get the best cheese on the market in Israel? And then the task is to identify duplicate questions. And we basically just used this data set to train our language generation model to generate the duplicate sentence or the different sentence. And we also thought about trying different models. So before we tried to use, so first we embedded the question answer pairs into embeddings, and then we created a vector out of this, and then we trained our model on those vectors. And looking for different models, you can find some language models which are more suitable for language for classification tasks, and some that are more suitable for language generation tasks. And we found GPT-2 and T5 to be useful in that sense. And in the next slide, you will see what the huge difference is in those models. So as I mentioned before we use a vector as our input that we created from those sentences. But now there's a different approach. We basically have a text-to-text model. So our input is text and our output is text. And here you can see a small experiment you can also do online. There's a website called Write with GPT-2. And basically it does autocomplete for text to write. And in this case, I just wrote original sentence colon and then an example sentence. And below that I wrote paraphrase sentence. and then I let the language generation model complete the sentence. And as you can see, it looks like a valid paraphrase. And this brings us to our new approach. We tried the T5 model. It was invented from Google. It's a transformer-based model, which I would say is very powerful. And our goal was to fine-tune it on our question-answer pairs and probably fine-tune it on the Quora data set. And the difference, or working with this text-to-text model, you can see in this GIF, in this example, instead of entering or giving a vector and awaiting and text output, you can just give a text input where you say the task at the beginning, and then the model will learn the task based on the text. So in this case, the task, as an example, was given translate English to German, and this is the input you give the model. So it's a different approach, and the results I'll show in a bit. We also thought about further ideas. For example, we could further try to filter out bad annotated examples from data sets, or try text masking or shuffling in words. And our first results with T5 are the following. So we just didn't clean a lot of the input. We just gave all the question answer pairs from the original sentence, and then added the word paraphrase in front of it, and then we just generated an output. And as you can see, the language model was able to recreate the original sentence from all those questions. And I think that's very, very interesting, because if you're creative, you could use this, maybe even if you're working with crowdsourcing information, and you just give all the information to the language model and let it clean the sentence, or generate like an average or a good example of the sentence. And so we were quite pleased with the results. But yeah, the problem, of course, is maybe that the output sentence is too close to the original sentence. So you kind of are in this difficult space where you want something like the original sentence, but you don't want the same one. So we tried further approaches. One is called fill in the blanks. Basically, you say the model, at this point, fill in n number of blanks. So in the picture you can see the model was supposed to fill in 4 words, and maybe the original sentence was just I love peanut butter and jelly sandwiches, and then it added a lot of words to that sentence. It's basically the same meaning. So this was one approach. Again, masking random words. If you leave a word out and you let the machine guess it, it may not be the same.
Yeah, and for masking, I can add that masking also can't be just done randomly completely. It needs to have some heuristic behind. So we did some work on excluding the verb, excluding some meaningful information of the sentence, like names and dates, and a lot of trying to understand what's the context that cannot be stripped, that cannot be masked.
Yeah, and at the end, we thought a lot about writing a custom loss function, which is a very difficult task in those complex models. And in this case, we would penalize if it would just output the same sentence as the input sentence. And with the T5 model, we were able to create a few examples. So again, the input paraphrase, and then the sentence, where did the term venture capital originate? And the output was, what is the origin of the term venture capital? So that was quite pleasing to have a stable model, because at first, sometimes the sentence were gibberish and or just the same sentence. And now we were basically able to create a paraphrase. But there were, of course, also some difficulties. And you can see that in the next slide. For example, the first sentence the meaning of the sentence or the logic of the sentence is completely messed up, and the output sentence doesn't make sense in that way. So you may run into problems with the logic of the sentence, and you may even just generate, again, we also came across this problem, a random sentence. So paraphrase steam can also be pumped, and the output was just steam, 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 steam. I don't know if you would say that's a valid paraphrase, but yeah. And the last example, I would say it's quite cool or quite amazing because I think it's useful, but you might say that's not a paraphrase, it's a summary. A man wearing a green shirt and a white hat climbs a tree, and the output is the man is climbing a tree. Yes, and this leads us to our conclusion. This sentence you probably heard thousands of times, but it's, I think, especially true in NLP, garbage in, garbage out. We noticed a huge improvement when working with cleaner data sets. We also stumbled across lots of the complexity and the size of the model problems.
Yeah, you might see a lot of CUDA memory overflows while working in such big models.
Exactly.
So one of the future works could be optimizing for parallel GPUs, because it's all we could use is only the minimal versions of all these models, like T5 small and BERT small, I think too. It's only maybe 5 to 10% of size of the real model that many people use in production.
And yeah, in the end, we were able to generate low forms of paraphrases, which was the initial task. We learned a lot about current state-of-the-art NLP models. It's a very fascinating topic, and if you follow it, you will see that the speed of invention is just increasing exponentially. So while we started this project, I think another 200 models came out during the last 3 months. So definitely there's a lot of things going on. And yeah, we learned a lot about its difficulties and limitations. And we would like to thank Guy and Ingo for their support, and also thank the whole Y-Data project, or the whole Y-Data school, for making this possible. And that concludes our project presentation.
Guys? Okay, time for questions.
I have a question about
How did you measure what was the loss function for the paraphrases?
So it depends on the model. Like for the first version, for sequence to sequence, for example, we had it's basically almost like a classification task. So they use how it's called, the log loss thing, right? So and for the T5, it's more complicated than that. Usually the loss that they have there, it's like a combination of different types of losses. It's also hard to measure because usually for these types of tasks, for the results, for example, how to estimate the result, they use this mean opinion score, which is basically a survey for people to answer on the form from 0 to 5, how well did the model achieve the task.
Okay, any other questions?
How did you go about training? Because these language models are usually very compute heavy. How did you deal with that?
So it's a lot of play with parameters. So the main one that affects it is the batch size usually, and the smaller the batch size is usually the slower the training. So it's kind of like balanced, but for T5, for example, we could only use the small T5, and then the batch size, I think 16 or 32. And it would use already 7 GB of memory. It could spike also to 8 and just crash. So honestly, when you work on this on production for real training, there is also room of optimizing the training process. It's just that we like didn't really deep dive into like optimizing the training itself, but it's possible also kind of to train bigger models on the, like, you know, the consumer GPU, like what we have on Amazon. I don't know, one instance, for example. It's doable.
Thanks.
I have another question, please, if you may. So first of all, it looks like you learned a lot, right? Because as you said, for the past 3 months, a lot of state-of-the-art NLP models came out, and it's kind of hard to follow, right? When you used T5 and GPT and all of the other one, did you eventually tackle the initial problem of question answering? Because I saw that a lot of results you got was text summarization, or compose a sentence, the original sentence from the questions themselves. The original task was to do this question answering, right?
The original task is paraphrasing.
So eventually, did you use one of the? Did you see one model was better than the others for the specific tasks? Because I saw a lot of models were used here. I didn't realize if eventually you used one of them, or how did you?
Eventually, our front runner was the T5. So we basically used the pre-trained T5, and also we fine-tuned it to using this supposedly paraphrasing data sets. Yeah, like this Quora, which Quora is more like semantically paraphrased, which is like more high level, because Quora sentences that are more semantic, right? Like it's like they give you like different questions and trying to understand if it's about the same thing, right? And there will be written complete different words. There will be no intersection even, right? So it's completely semantic. So we tried that, but didn't really see real improvement. So yeah, T5 was basically our best shot, I think, here. Like, of course, like now for paraphrasing, like there are already existing models, you know, like GPT-2 and GPT-3, which is not really publicly available at the moment. Maybe it will never be, but those can create, you know, articles for you from a couple of tags and a prompt of a sentence. So this project was like trying this concept of trying to create a paraphrase given this question answer data set. It was like a small research, basically.
Okay, thank you very much.
Okay, thank you. Thank you, guys.
Thank you, everyone.
Thank you, guys.
Okay.
Kostya, today we don't have the clapping, the pre-trained clapping sound.
Actually, we have. Okay.
Pre-trained clapping.
We need more oomph, you know, some horns also, some.
Okay, we'll go for that. Okay, the second one, dynamic yield.
Okay, hi guys. So Rina and I will present, and Rina actually will do most of the talk, and I will do the conclusions. So Rina, do you want to share the screen?
You're on mute, Rina.
Can you see my screen?
Yeah.
Okay. Hi. So the dynamic yield project